sine over cosine, right? Right, tan is sine over cosine. We remember that. It's the ratio. So here at 0, we get 0 divided by 1. It's 0. When we go over to pi over 2, cosine is 0 at pi over 2, and we get that asymptote. Right? So, and then here at pi, we have 0, and then we have negative 1 for cosine. And then at 3 pi over 2, we have a 0 in the denominator again. And if you remember, in between, right, if we draw on our unit circle, between pi over 2 and pi, so here's pi over 2, here's pi, that's a pi. We've got positive sine, negative cosines, we have negatives here and positives there, so we get this graph that looks like that, basically. In the range, because remember this is theta, and this is y, because we're graphing that. The range here that we're going to get for our y's is all of those. So here the range is all real numbers. We're getting all of these. All the ones going down, all the ones going up. This is tangent function. Cool, so we've got our domain and range. We don't yet know what our graph is going to look like, but we know the bounds for it. So let's go about actually finding what this is going to look like. Here we got secant and tangent. It's different than sine and cosine. So we're going to be like, I know, sine squared plus cosine squared equals 1. Oh man, there's only a way to turn a sine into a tangent. Right? Tangent is sine over cosine. Let's just divide everything by cosine squared, right? Remember? Or you can remember your other properties. Right? Divide by cosine squared, divide by cosine squared, divide by cosine squared. That gives us tangent squared theta plus 1 equals secant squared theta, or 1 equals secant squared theta minus tangent squared theta. Ooh, some of you might be recognizing kind of where this is going now. I'm not going to give it away yet. Now what we want to do is like, hey, I've got this lovely property between secant squared and tangent squared, this equation, this Pythagorean identity that we can use. And we've got stuff with secants and tangents. So let's solve for secant, let's solve for tangent, then square it, and put those in for the equation. So let's go to x. So x equals 1 plus 3 secant theta. I'm going to subtract 1. So x minus 1 equals 3 secant theta. Divide by 3. X minus 1 over 3 equals secant theta. I want secant squared, so I'm going to square it, and square it. So I squared the x minus 1 to go x minus 1 squared. Squared the 3 squared x is right 9. And then secant squared. All right, now I have y equals negative 3 plus tangent theta. Here I just add 3 to each side. Y plus 3 equals tangent theta. And then I want tan squared, so I'm going to square both sides. And make sure you're using those parentheses. Y plus 3 squared. And the denominator is just 1, so you can put a 1 squared on the bottom if you want. You don't have to. Well, look at this. We got a secant squared, we got a tangent squared. We can now write this out. Let's use this. We can say 1 equals secant squared, x minus 1 squared over 3 squared, which is 9, minus tangent squared, which is y plus 3 squared. I'm like, what if I did this over 1? What's that the equation for? This is my rectangular equation. That's the equation for a hyperbola, right? So this gives us a hyperbola. So now what we gotta do is we gotta graph that hyperbola, identify the characteristics, and we're done. Cool. And we're gonna graph it with this domain. So let's look at some key characteristics here. Get purple. Key characteristics. Oh yeah, I forgot purple's kind of squeaky. Let's not use squeaky purple. Well, the center is going to be at 1, negative 3, which is, well, the 1's not in our domain. So we're not going to graph the center, but that's okay because the hyperbola doesn't actually go through the center. Where would the vertices be? Vertices are going to be right or left 3 from the center, right? Because a squared is 9. Right, a squared is 9, so a equals 3. So we're going to go right. If I go right 3, I'm going to be outside my domain. If I go left 3, -2, -3, here we just get one of them that we're graphing because we can only be -2 and to the left, which is telling us we're just going to get this left side branch of the hyperbola. All right, and then let's actually go back and graph this thing out. So here and here, the center is at 1, -3. -2, -3 is one of the vertices. And I've got a vertical up 1 for my b value, down 1 for my b value. And 1, 2, 3. Because we still have to draw in these asymptotes if we want to sketch the graph. So here this tells us our asymptotes are going to have a slope of 1/3, positive or negative. It doesn't matter necessarily which one's a or b when we're talking about the asymptotes for hyperbola. It matters which one's in the denominator of the y. That's our rise. So here, the 1 is the rise. The 3, the square root of 9, is our run. So the asymptote equations are going to be y plus 3 equals positive 1/3 times x minus 1, or y plus 3 equals negative 1/3 times x minus 1. That's what's going on here, that 1/3 and negative 1/3. But now for what we're actually graphing, we're only graphing this section here, because we only get the ones that are the part of the graph that's less than or equal to -2. So I'm going to sketch that in. But I still need to figure out where the arrows are going. So if I look at this and I go like, all right, let's just check it out. For here, when are my y values negative, right? These are the negative y values. That's to the left of pi, right? If I go to like 3 pi over 4, I'd have a negative y value. So negative, 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 up to here, and then it's going to go positive. Oh my goodness. Hopefully you caught this earlier. This should be at -3, and that's at 0. Wow, that was a big goof. You're probably yelling at me. I know some of you were. You're like, Mr. Race, you goofed that up. Yeah, I did. Sorry. Don't worry, this is all real numbers. Oops. Still, doesn't change it, but yeah, that would make sense. That this right here, this is when it's at pi. Oh, no, it's not at pi. It'd be right there. Corresponds to that spot right there. At pi, we're at -3. Wonderful. And then as we get close to pi over 2, right? Oh, this shouldn't be equal to either. Yikes, I'm just goofing up all over the place. Sorry. It was written correctly on my document that I'm looking off of. So here, we're going this direction. Because as we go from pi over 2 to 3 pi over 2, we're going negative y's, negative y's, negative y's, negative y's, 0, positive y's. So that's the direction there. And there's no starting or ending point because it's this full branch of the hyperbola. So, hopefully you were able to follow along with this kind of a train wreck of a lesson. I'm going to make another video with a couple more examples. Hopefully those will go more smoothly. I'll still be available for office hours this week. Good luck, and thanks for watching.